In this video, we shall continue to discuss some basic concepts in electric circuit or in electricity. After that, we will discuss the typical syllabus for basic electrical and electronics engineering subject. So the syllabus varies from one university to another university, from one college to another college, but a simple, a typical syllabus we will discuss for this channel. So we have in the previous introductory video, we discussed about Ohm's law. So we will recall that Ohm's law, I equal to V divided by R, where I is the current in amperes, V is the voltage in volts, and R is the resistance expressed in ohm. Also, we have seen three forms of Ohm's law. So here the voltage, they have used the letter E. So E actually stands for electromotive force. So that notation also some books they follow, especially old books, they follow this notation E for voltage. But the modern usage is capital V. So both E and capital V represents voltage. So we have three forms of Ohm's law. One is current I equal to V divided by R ampere, and V equal to I into R, and R equal to E or V divided by I. So let us illustrate this by a simple example. So here you consider, I will take the pen. So we have a battery whose voltage is 36 volt, and we have a lamp. By means of wires, the lamp and battery are connected. Suppose if you assume electron current will start from negative terminal of the battery, it will end at the positive terminal. Since we are normally assuming conventional current flow, so the current will start from positive terminal, it will go through the lamp, it will reach the negative terminal of the battery. So the current flowing through the circuit, I, is given as 4 ampere. So this lamp has got some filament that offers some resistance. Okay. So the question is, what is the amount of resistance R offered by the lamp? So we need to find out resistance. So this formula applies. So resistance equal to voltage divided by current. So we use this formula R equal to V divided by I ohm. So V is nothing but 36 volt, I is nothing but 4 ampere. So the resistance R equal to 9 ohm. Next we have just not a detailed explanation, but just a basic introduction. These simple circuits, there are two types. One is called series circuit Another one is called parallel circuit. So in a series circuit, the various components will be connected one after another. We will discuss in detail in further classes the concept of series connection, concept of parallel connection, the concept of series parallel connections. Now just a basic introduction. So the components are connected one after another, that is all in a row, one path for electricity. So here the current will start from positive terminal, it will flow through all the three lamps, it will reach the negative terminal of the battery, right? So same current flows through the entire circuit. Suppose if one of the light goes out, the circuit gets broken, the circuit becomes open circuit and hence no current. Okay. So this is the concept of series circuit. So another simple circuit is the so-called parallel circuit. Here many paths for electricity. So we connect the positive terminal of the battery connected to the positive terminal of all the three lamps and the negative terminal connected to the negative terminal of all the three lamps. So we have three separate paths here in this case. Three separate paths for the flow of electric current. Suppose if one light goes out, but in that particular path current will not be flowing, right? But in the other two paths, path 2 and path 3, current will be flowing. So those two bulbs continue to glow on. So what is the idea is the current will flow, say this is positive. So current through this current will flow. So this bulb will be glowing on. Similarly, through the third bulb also current will be flowing. So this bulb will be going on. Suppose this bulb comes out, no current will be flowing. Okay. So this is called parallel circuit. So our household connection is parallel circuit. Okay. Suppose if you switch off one light in one room, only that light will be switched off. The fan connected in that room will run, or other lamps connected in that room that will continue to operate. So in our household we are following the parallel circuit or parallel connection. Next, power in electric circuit. Power is a measure of how much work can be performed in a given amount of time. In electric circuits, power is a function of both voltage and current. So we can write power P equal to V into I. When using this formula, the unit of measurement for power is the watt, abbreviated with the letter capital W. Now I will give a very brief introduction, not detail, just a very brief introduction to AC circuits. After this, we will go to the typical basic electrical and electronics, popularly called BEE syllabus. So, introduction to AC circuits. Electricity is produced by generators at power stations and then distributed by a vast network of transmission lines to industry and for domestic use. So for our house, the electricity supplied is AC or alternating current. It is easier and cheaper to generate alternating current AC than direct current DC. And AC, that is alternating current, is more conveniently distributed than DC since its voltage can be readily altered using transformers. Next, we will see the description of typical syllabus. I will expand this. So it's a typical syllabus, right? Basic electrical and electronics engineering. So some of the objectives of this subject, and it is common to most of the branches. Some of the objectives of the study of this subject: to understand the basic theorems used in electrical circuits, to educate on the different concepts and functions of electrical machines, to introduce electron devices and its applications, to explain the principles of digital electronics, and finally to impart knowledge on the principles of measuring instruments. So this course we have 5 units. So unit 1 discusses about electrical circuits or electric circuits. So the various concepts surrounding the electric circuits, basic concepts. We are not going to study in detail. Suppose if you want to study in detail about electric circuits, and we have a separate course called circuit theory. A separate playlist is available in this channel. Suppose if you want to study that subject, or if you want to learn electrical circuits or electric circuits in detail, so you can go through the playlist given in this channel, Triple E with Professor RKN, where you will get a very detailed explanation of electric circuits or circuit theory. So in this unit, only just a fundamental concepts we are going to study. So the various syllabus in this unit are Ohm's law. We have already seen basic introduction of Ohm's law, and Kirchhoff's laws, steady state solution of DC circuits using mesh and nodal analysis, introduction to AC circuits, waveforms and RMS value, power and power factor. Power in general we have already seen in this video, but power in AC circuits and power factor we will discuss in unit 1, and single phase and 3-phase AC balanced circuits. So only basic concepts or introductory level of study of electric circuits. So the unit 2 deals with the electrical machines. Here we will discuss about construction, principle of operation, basic equations, mainly that is EMF equation and also torque equation, and applications of DC generators, DC motors. So you'll also study about single phase induction motor, the concept of single phase induction motor, and probably its different types of induction motor, single phase induction motor. Also we'll study the basic concept of single phase transformer, probably the types of single phase transformer. Next we shall move on to unit 3. So here we are going to study about basic electronics. So unit 3 deals with semiconductor devices and applications. So here first you will study characteristics of p-n junction diode, Zener effect, Zener diode, LED means light emitting diode, photodiode and its characteristics, and then we shall go on to study the concept of half wave and full wave rectifiers, voltage regulation. Next we shall study the principle of operation of BJT or bipolar junction transistor, and one of the most employed configuration of BJT or bipolar junction transistor, which is nothing but common emitter configuration, characteristics in this configuration, and common emitter as an amplifier. And we also discuss photo transistors, right? Next we have unit 4. It is an introduction to digital electronics. See, nowadays almost the entire world is digital. So the watch you are wearing is digital, and smartphone you are using, cell phone you are using is entirely digital. Your computer is digital, your laptop is digital, your tab is digital. Likewise, the entire world has become digital. So this digital electronics is a very important and very basic subject. Whoever is going to study electrical and electronics engineering or EC, electronics and communication engineering, and CSE, computer science and engineering, or instrumentation engineering, or even IT people. So for these disciplines of study, digital electronics is the very fundamental. So in this unit we shall study the very fundamental aspects of digital electronics. So the topics covered in this unit 4 are number system conversion methods, simplification of Boolean expression using K-map, half and full adders, flip-flops, shift registers. There are four types are there. SISO, single serial in, serial out. SIPO, serial in, parallel out. PISO, parallel in, serial out. And PIPO, parallel in, parallel out. And we will also study 4-bit synchronous and asynchronous up counters. Next, unit 5, it discusses about measuring instruments. First it talks about types of signals, analog and digital signals. What is an analog signal and what is a digital signal, and the difference between these two signals. and then construction and working principle of moving coil instrument and moving iron instruments. So mainly ammeters and voltmeters. And then watt meters, for example dynamometer type watt meters and energy meters. Also we will discuss about instrumentation amplifier in a very simple form, and D by A converter or DAC, that is nothing but digital to analog converter, and one type R to R ladder type D to A, digital to analog converter we will discuss. And finally we will discuss A to D converter or ADC, that means analog to digital converter. Here we will discuss about two types of A to D converter, that is a flash type and a successive approximation type analog to digital converter. So the outcome, suppose if you complete this course, what you can do. Okay, so these are called COs or course outcomes. So we have 5 course outcomes. Course outcome 1 is compute the electric circuit parameters for simple problems. CO2 course outcome 2 is understand the construction and characteristics of different electrical machines. CO3 describe the fundamental behavior of different semiconductor devices and circuits. And fourth outcome CO4, you can design basic digital circuits using logic gates and flip-flops. And course outcome 5, CO5, analyze the operating principle and working of measuring instruments. So this is introduction to the course, and the books recommended. So textbooks, they have recommended 2 things. One is Basic Electrical and Electronics Engineering by Kothari and Nagarath and Kothari book. And for electronics, a textbook of Applied Electronics by R.S. Seda, and some references they have given. Muthu Subramanian, Swali Vagadan, Muralidharan, they have also written one book, Basic Electrical Electronics Engineering. And V.K. Mehta, Principles of Electronics is another reference book. And Maurice Bano, Digital Logic and Computer Engineering. And this electric circuits by Edminister and Mahmoud Nahwi. So to solve a number of electric circuit problems, you can refer to this book. So in this video, just we have recalled the some very, very fundamental introductory concepts of electric circuits or electrical engineering, and we have also seen the syllabus, right? Introduction to the syllabus of typical syllabus of basic electrical and electronics engineering. So we will try to discuss this syllabus in the this syllabus in detail in the subsequent videos. And I thank you for your continuous support and patronage. Thank you very much.